So we're going to do a little bit of, we're going to learn one more last pattern for factoring. And then I think there's a few different kinds of examples down below that we'll look at, just different kinds of questions, things to watch out for. So let's take a look at what we have here. We have this kind of random setup. It doesn't look like there's much going on here. I mean, there's sort of patterns, but let's expand it. So a times a squared, a cubed, and then a times ab is plus a squared b. A times b squared is plus ab squared. And then multiplying the b's, so negative b times a squared is negative a squared b. Negative b times ab is negative ab squared, and negative b times b squared is negative b cubed. Everybody okay with that? So what do we notice? A squared b minus a squared b. ab squared minus ab squared. A cubed minus b cubed. So what do we call that? Difference of cubes, just like a difference of squares. So we can use that to factor. If you ever are looking at a difference of cubes, then it factors back to that. And what is that? Well, we'll do an example which will help, but it's like the cube root of the first term minus the cube root of the second term. And then once you've got that first bracket, you square the first term, square the last term, and multiply the two terms together. Easy enough? What about this one? So we're going to do the same thing. A times a squared, a times negative ab. Go on. I'll let you try that one. Go ahead. So what will we call this? It's not a difference of cubes. Yeah, sum of cubes. I think it's in the title, right? So sum of cubes. So you've already learned in the past about a difference of squares. You know how to factor that. We saw one of those yesterday, I believe. There is no sum of squares. That does not factor. People, when they... And oh my goodness, if any of you do this, I'm going to scream, but that happens usually every year. A squared plus 16 is a plus 4 squared, right? But this is like a huge mistake. This is bad stuff. That's a grade 10 mistake. You shouldn't be making it in grade 12, right? There is no sum of squares. And if you expand a plus 4 all squared, you absolutely do not get a squared plus 16. So those are not equivalent expressions. They're not equal. If I expand one, I don't get the other. So then factoring is not going to work either, right? That could be your proof or your counterproof. But there is a sum of cubes. That does work. So there's both a difference of cubes and a sum of cubes. And you just have to learn the pattern. It's like a formula. You got to learn it. So again, you take the cube root and the cube root, and it's the sum, whereas the other one was the difference. And then again, you square them both, and the middle term is the product, but you notice that the middle term has the opposite sign in each case. So if it's a sum of cubes, the middle term is negative. If it's a difference of cubes, the middle term is positive. So look for those, because people do get that backwards. Look for those little patterns and just memorize that. Okay, so that's it. So let's take a look at the first one. What is it? It's a difference of cubes. So if I'm going to factor it, I get x, same sign, 2 Cube root of x cubed is x. Cube root of 8 is 2. A lot of people know their square roots. Not as many people know a lot of cube roots. But if I saw like x cubed minus or plus any constant, I'd check it to see if it's a perfect cube, right? That's probably the case. Okay, and then the trick is, that part's probably easy. The trick is, how do you come up with the second part? So this is x squared plus 2x plus 4. So you're squaring x, squaring 2, and then the middle term is the two of them multiplied, 2 times x. But not like negative 2 times x, right? The signs we saw before, if you ever wondered, well, why is it, I don't understand why it's positive 2x. Well, we saw up here why it's positive 2x. That's how it works out. So the last couple of days as we've been factoring, I've talked a lot about, it's important to know, like, to think about the expansion whenever you're factoring. Okay, so same thing here. And then you could do little quick checks. I mean, you could re-expand the whole thing kind of, but I would just make sure negative 2 times 4 gives you negative 8. Like, look for those patterns. Just good habits to do a little bit of check. Any questions? Why don't you try this one? So it's a sum of cubes, 3x plus 7y. Again, if we match it for the signs from that first example, if you're looking for the signs. And again, we've got 3x all squared. We've got 7y all squared. And then that's 3x times 7y. And it's got the opposite sign, so it's negative. Any questions about that? We're going to do a few more examples, but that's the new stuff for today. So now we know how to factor like higher order polynomials in general, and then this one little sort of special product case, the difference of cubes and sum of cubes. What's going on with this one? Alex. You can cube root both of them. Very good. What's the cube root of x to the 6? 2, x squared, right? So again, like any multiple of 3 will work. So it's gonna be x squared, and what's the cube root of 729? How do you figure that out? Start guessing at things that it might be and just figure out what is it? I don't think so. 9, right. Okay, and then the first term squared, the two terms multiplied together, and the last term squared. Done? Not done? Oh, good catch. If you thought you were done, you're not playing by the rules. Remember, you always look especially when you have these weird questions that have like bigger exponents, always good. So what are we missing? Yeah, what do we call that? Not taking the square root, but yeah, it's a difference of squares. So x plus 3, you should be pros at this, x minus 3, and then x the fourth plus 9x squared plus 81. Yeah, question?
Yeah, couldn't you, for that last one, Steve, couldn't you also factor x to the 4 plus 9x?
Can you? So that's a good question, and it would be interesting, like always good to kind of double check everything, right? But two numbers that, it would be a simple trinomial, so two numbers that multiply to 81 and adds 9, I don't think so, right? So in this case, nope. But always good to check every bracket you have left, unless it's linear. If it's linear, if it's x minus 5, that's not going to factor any further. If it's 2x plus 10, common factor, right? But if you end up with a common factor at the end, you should have probably common factored a long time ago. So, like I said before, every one of these is just use what you know, everything, plan your attack. So what would be my first step for this one? I hope it's obvious. Somebody else. Alicia, what do we do? Yeah, common factor out the A. And then anything else? Like, is there any common factor in the 8 and the 125? No. So 8a cubed plus 125. And what is that? Michelle, do you know what that is? It's a sum of cubes. 8's a cube. 125 is a cube you probably recognize. So go ahead and you can try to finish that one. Whoops. See, that's what happens when you go fast. A squared minus 10a, right? That should be minus. Always flip that one. Everybody got that? So 2a plus 5 and then rest. What's going on with this one? This is like a grade 10 question. Hard grade 10 question. But something that I would have encouraged you in grade 10 to think about. Like maybe you wouldn't end up being super successful with these kinds, but there's different strategies you could use. But in the end, it's one, that certainly in grade 10 you would be able to solve. But now that we're in grade 12, we should be able to, and we should be sort of better at recognizing these things. These hard questions should become easier for us. So Alex, what do you think? Yeah, it's a difference of squares, right? The first thing is a perfect square because it's something squared. The second thing is a perfect square because it's something squared. And it's the difference between the two. So there's two ways that you could do this. The simple way that is in grade 10, people who don't get it, what I would recommend to do, you could expand and simplify, and it'll always work out that way. Right? You can always expand and simplify, and it'll be if it's factorable now, it'll be factorable then. It can't not be. Okay? But the nice way to do it would be like this. Like, how do you do a difference of squares? It's the first thing plus the second thing, the square roots, and then the first thing minus the second thing. Right? So if this was a squared plus b squared, it'd be a plus b and a minus b, right? Everybody happy with that? You okay with that? If you're not, just pick an example like we did before, x squared minus 9, and look at it and think about it. But a is x minus 4. And b is x plus 1. X minus 4x plus 1. That's the thing that was squared. Like normally you see it as x squared minus 3 squared. X squared minus 9. But the whole point of the pattern is it's something squared minus something else squared, right? That's the pattern. So we can do this. And the only real set of brackets we need is that one right there, because the rest of them we didn't need, but that one we do. So this is x plus x, which is 2x minus 3. And this is x minus x. So that's actually gone. And negative 4 minus 1, which is negative 5. Well, that's written in a weird way, but it would, I guess you wouldn't have to rewrite it, but it would look like this. So if you expand it, you'd actually get something that's really easy to factor, but anyway. Everybody okay with that one? What about this one? Another grade 10 kind of question. Even if you weren't sure about this one, what would you notice? Justin? It is a difference of squares. How can you tell? Like, what do you notice about it, even if you don't see it as a difference of squares? Alex? Yeah, every number is a perfect square. Like, everything in there is a perfect square. So I would at least be curious that there's something going on there, right? But you should remember about fractions that if I have like 2 over 3 all squared, that's like 2 over 3 times 2 over 3, which is 2 times 2 over 3 times 3, which is 2 squared over 3 squared, right? Or same thing going backwards, the square root of a over b is equal to the square root of a over the square root of b. These are things that you've learned. Or I hope so. So these are perfect squares. If I could take the square root of the top and the bottom, I could take the square root of the whole thing. And it works out to x over 3 plus 4 over 5, x over 3 minus 4 over 5. Easy enough? Let's try another one. Oh, this one's easy. X plus 7 squared. Roman's shaking his head no. But why is that wrong? What's the answer to this one? Yeah, nice. Not factorable. Oh my goodness. If nothing else, just memorize it over the March break. Sum of squares is not factorable. It comes up once in a while, and people do get it wrong. So, just like people do this. Oh my goodness. X plus 5 squared. People, because they're out of practice and not paying attention, do that. Oh my gosh. Give me a heart attack. Okay. Last one. Have you seen a question like this before? Yeah. What's happening in this one? Yeah. Yeah, it is. And if you don't notice it, imagine I replaced x plus 3 with y. So it's y squared plus 4y minus 21. And this is a trick that you could use, like off in the margin on a scrap piece of paper, and factor that. That's an easy one. And then replace the y's back with x plus 3, right? So but I would do it like this. Two numbers that multiply to 21 and add to 4, so positive 7 and negative 3. And instead of x minus 7, x minus 3 and x plus 7, it's x plus 3 minus 3 and x plus 3, minus 7. Make sense? Probably, I'm guessing maybe that doesn't make sense to some people. That's going a little bit fast. But think about it and ask if you're not sure. But it's just a matter of it clicking and seeing it. And then, of course, we're going to simplify. Was that your question, Alex? Yeah, of course. X plus 10. And again, for questions like that, in a pinch, you can expand and simplify, but it's quite a lot slower. You would end up with something that's pretty easy to factor by the looks of it. But, you know, even if there's an, like, quote unquote, easier way, it doesn't help your thinking and your practice and your sort of algebra, like your abstract algebra skills of reflecting on these things, right? So sometimes those shortcuts end up actually hurting you more, taking those shortcuts. Well, it's not even a shortcut because it takes longer, but you know what I mean. Shortcut in thinking. Any questions?